Hello, everyone. I'm so glad to see so many people offline here at Devox. Uh, that's really great, despite this is the last slot in this day in the conference. Well, thank you for coming. Uh, we're going to talk about containers and their sizes and their performance, well, at least from the perspective of some Java applications that can observe that. Well, we'll try to play a Doctor Who, just a little. So I'll be the doctor. By the coincidence, I came from the country where they really wear faces. You see, my name is Dmitry Chuyko. I work at a company named BellSoft. I'm an OpenJDK committer, and the company does a lot in OpenJDK. So we contribute to OpenJDK, and we release our own OpenJDK distribution called glibc, which is, by the way, the default JDK that appears if you build a Spring Boot container with classical JVM. Just check it out. So all that containers, what they are all about, why do they need them? Well, obviously, everyone nowadays uses them for a kind of simplified management of your environment, for having separated configuration and all the knowledge about how your code runs, reproducible environments, slight isolation, not the true one, but still. So how we actually put a container somewhere? While we prepare an image and we start that image. So how do we deliver that image to somewhere? Actually, we can just package an archive and send it to another machine or start it in our machine. It's just a descriptor, so it contains all your application code, necessary files, configuration, whatever, and metadata to start it and to provide some resources. That's not really a complex thing. Well, there's a lot of information, but still it's rather simple. So you can actually do that yourselves. You can export a container as an archive, transfer it somewhere, and sometimes it's really helpful. Well, still we don't do that too often, right? We probably rely on container registers because they are so convenient to store our images and to provide them on the machine, right, to create layers. So when we use registry, we rely also on some images that we combine with our code, and then we put it in a centralized place and distribute it over the actual production nodes. At the same time, we cross network boundaries. Maybe not so visible here, but our development machine, our registry, our production for sure can be physically located or logically located in different networks. So there's some traffic, so we need to transfer that code, the data, to registry, from registry, and this registry can be owned by different parties. So it can be a one on the development machine, so we can actually start a reverse proxy to deploy start our production using access to our developer machine. Nobody really does that, but it's possible. We can leave it to a third-party registry, software as a service provider, like cloud provider, or we can leave it to services like Docker Hub, right? So it's just important to remember that it sometimes depends what network boundaries do you really cross. Then you perform uploading images, and then you pull them. So again, even if you rely on some bigger registry, you can start your own proxy to help reduce the number of accesses to that bigger registry. Well, why would we do that? Because there might be some limitations. And those are limits. We now live for 2 years with those limits, but still, sometimes people just do not know that they really apply. Also, if we go and try different options, we can get some free service. But if we operate the containers really a lot, we'll probably have some payments. Why? Because we spend traffic, we spend CPU time, we spend storage. So if we spend it a lot, you'll probably be charged. Well, again, it depends on the network boundaries. When you cross a network domain, or region boundary in a public cloud, you have to pay. Well, it seems like not a problem, and even if we consider it a problem, which actually we do, it really looks that small containers can help. So you have less traffic, right? You have less disk storage for smaller containers. And I think that small containers are just like TARDIS, because they are small from the outside and they are really powerful from the inside. Well, why do we use and build small containers, and how would we do that? We build images typically based on someone else's work, right? And that someone else's work is a base image. We can call it a parent image, which is more strict, but I'll say just base image. And for us, JDK providers, base image should contain JDK. That's obvious, because you just consume something working, something to run your jar file or a bunch of jar files, your Java application. And these base images, what do they look inside? There are layers, of course. Something very, very basic. The scratch layer, an operating system layer, which actually provides you a means, typically then you run in a normal environment, to access hosts, kernel provided functions. And also some standard functions available for example, for Java runtime, which is the next layer, right? Java runtime may require some OS packages. So you see that OS packages layer is kind of splitted on this picture. And you may as well require operating system packages for your application. Well, why not? You can require something special from your operating system environment. And then we all use libraries. We use frameworks. We use libraries dedicated for specific tasks that might be native libraries or Java libraries, whatever. And I think it's a normal situation when the amount of code in libraries is larger than amount of code that you write to use them, right? Otherwise, why do we need a library? And that our code is the very tip of this iceberg. These layers also help to reduce traffic, because if we update a layered image, we only need to update top layers that really changed. Like if you use ThinJar or lay the layers, for example, and then we use Spring Boot, we can create content for layers, or build can do that automatically for us. We'll get the top layers splitted and also the bottom ones, the JDK and operating system. And it depends on how we build our containers, how we build our images. People still do it differently, and I should say there's no right or wrong way in doing that. You see, you can use Jeep, you can use Paketo build packs. They all work. You can write Dockerfile yourself. This is probably still the dominating way of preparing images. Absolutely not bad. I do it myself. There are some interesting pitfalls in resource usage, but that's a subject of slightly different talk. The interesting point here is that what resulting images, what are their sizes, what are their performance if you go all different routes to create your image. Well, if we talk about size, first we can optimize what we control mostly, right? The top size of an iceberg, top tip of an iceberg. We can try to split our application into smaller parts, like microservices, real microservices, not just monoliths that are deployed in many instances. We can try to use more effective libraries that will be smaller, more effective operating system packages. And here we go to the base layer, right? Because probably we can think of using more effective OS image that will provide always the smallest packages, whatever packages do we use. So it's interesting that we can try to compare different OS images, right? There's no a single criteria which says this one is better, this one is worse, because you have to know your requirements. This is some external comparison, so you see links. And you can choose whatever criteria is applicable for you to select the image. But you see, we'll say it slightly later, that the resulting size greatly varies depending on what you have chosen. So now think about combining operating system image and JDK. It's not that smooth if you just combine two parts together. They won't be one part magically. So you probably need some clue. How it happens? Well, there's typically some provider that provides such images, and there must be some testing around that, right? And the way how JDK is put in such an image is not that important. It can be installed as a package of this system, as kind of from default repository or from some external one, or it can be installed as a binary. Anyway, it should be tested as a whole, together. Well, there are some options to decrease your JDK. Of course, you can use JLink, but again, you should start with a proper image, and you must understand how your custom runtime clues the OS. And we can rely on smaller OS images. So let's look inside. We can actually diagnose layers in our containers. It's not that complex. We just unlock some diagnostic options. Well, not VM this time, but for Docker. And we can inspect layers. And there's information about their sizes, also their digests. And you see, it's an interesting image. Like, let's check it again, right? The image is called OpenJDK. Whoever used that? All right, about a half of the audience. So I don't know what others used, but we'll see. Anyway, you just take something that's called OpenJDK and you expect it to be, suitable for your production. Well, first, it's huge, right? We just take this image, and it used to be even larger than half of a gigabyte on your disk. And what's even worse, this large image is pulled on not so slow network in half a minute. Are you ready that you're waiting for that time, or your production is waiting for this image to be pulled for such a long time? Of course, if the network is faster, the pull time is also smaller, but you still wait. The worst part, if you go to Docker Hub and read the description of this image, you'll see that it's deprecated and no longer updated. wow, why you're still using it? Just there's some list of so-called official images supported by some Docker Hub stuff. And there are other images that are not called official, but still good. Well, what would we get? I had some construction game of mind. We just can imagine breaking some limits, crossing some boundaries, like region boundaries, spending storage, having a lot of deploys, right? We're just getting charged, right? And what's worse, how typically deploys happen, right? We want them fast. Maybe we are not doing that like all at once, right? We just deploy a new version to some nodes and wait for it to bake to prove that it's stable enough. But still, we deploy a lot at once. And at this time, especially if you're not using cloud providers' resources, that's your resources, you just have a huge traffic flying around. That's terrible. Now look at different base OS images that you can actually choose. There's a great variety. These just some images, some of them. And for those images, this difference in size is like 10 times or 20 times. There's one very special among them called Alpine Linux. It has package manager, it has a shell, it has a standard C library included, and it's only 3 megabytes, less than 3 megabytes over the wire. Right, that looks promising. But you see, the names here in all that columns are slightly unfamiliar. And if we look at other images, yes, they can be slimmer than 80 or 100 megabytes, but still much more heavy than Alpine. Well, you can build, and that's what we do, an effective OS plus JDK image based on some slim ones. But still, Alpine will be very slim. And in our case, we also prepare JDK, which we call JDK Lite, which is slimmer than a regular build. And it's still tested the same way. It's just more lightweight, more suitable for real cloud usage. Well, then they come to this. You see, our 28 seconds turned into 4 seconds. You just type the command and you have your JDK up and running in a container. The exact version that you need. It's like click and it works. You can instantly run your Java application if you don't have JDK installed on your machine just using that container, right? Just provide the right command line and that's it. So obviously, small containers do help. And we'll see how they work, what's inside. Well, the magical tool that powers such small containers is the basement, is the OS. So what I've shown you so far is Alpine Linux. It's a special Linux designed to be small, secure, and conform standards. And it's based on a standard C library implementation, which is called musl. Well, you see, you really need standard C library, then you run your Java program. Why? Because you run it in a JVM, and JVM is a native executable. So it uses system libraries to run. And this particular implementation, among many others, right, as I said, is targeted to be very simple. The code is very clean, to rely on what's written in standards, not just, to have safe behavior, then the behavior is undefined, etc. And it also has nice features like UTF-8 support and some others. Well, how do we compare that libraries, right? If there are options, how do we choose? Or if we develop such a library, how do we compete with others or compare or realize what's missing in our implementation, right? Or where are we better? Well, there are some tests. Here are like developers of musl were concerned and really did a great job in comparison with other libc distributions. Small ones, big ones like glibc, this is the one that they typically meet, right? It is huge. mulibc, which is even smaller, I think, and so others. You see, criteria here, they are related to correctness, they are related to performance, right? They are related to undefined behavior, to safety, to security of our applications. And some libraries are better than others in something and worse than others in something else. Well, doesn't look like a problem. And you see the many green light here from musl, right? So this can make us sure that, yeah, the quality is good and we can actually use that. Well, how does that relate to our Java programs? We'll see it slightly later. And in this slide, you can also see support for different CPU architectures. That's what we see right now. We now use non-x86 CPU architectures in public clouds, on desktops. That's our reality nowadays. Currently, it's mostly ARM64, right? If you talk about backends or related development, but that's not the only thing. Also others. Well, as I said, JVM HotSpot is a C++ program, and if you look into its source, right, it's open source, OpenJDK, you'll see that it indeed requires a standard C library. Well, and it's a different one, not glibc one, which means that probably if you're a provider of JDK, you have to build it somehow and test it somehow. But we'll get to it slightly later. Another component of Alpine and Alpine-derived Linuxes is BusyBox. It's a special binary that pretends to be all other standard Linux binaries, standard commands. It's just a single binary, it has links to it, and we can execute normal command lines, but we actually fall down into the same library, which is, the binary is compact again. It shares a lot of functionality, it's built to be small and portable, and it really makes it easy to build such a distribution, which is small. Again, if you work with different implementation of standard tools, there might be differences related to the behavior not covered by the regular specification, by the regular standard. But BusyBox tries to follow the core standard, right? And also, I forgot to mention that musl really includes few extensions to standard popular ones, but it's not glibc compatible in general. So, besides of that components, we have a package manager and initialization system, and APK again is slightly different, different command lines to install your packages. But it's a package manager we're used to. We just say, well, add some package and it's installed and its dependencies are installed as well. And it looks like that Alpine Linux as a base OS is perfect for small containers, which will help us to reduce traffic, the storage, and probably bring some other benefits. Well, yes, that was realized in the JDK community. And now, since JDK 16 from 2020, there is an official port to musl C library for Linux. So you can take any downstream distribution. The recent version will be based on the very same code that supports musl. And it wasn't like an instant port. It required some work. So it was covered by a JEP 386, delivered by BellSoft, but developed by multiple companies. And it all started as a project in OpenJDK, Project Portola, by Michael Wittstedt, and we just took that work and brought it to actual JDK mainline. So now it's there, but what's inside? What this project is about, right? Then you create such a port. You have to describe or provide means how to build such binaries, some instructions, some helpers. And it's actually described in OpenJDK documentation, and that can also be used to build your user binaries, right? Where do we have native binaries? We have them in JNI. Or other libraries that we can access with other means like Panama or some third-party libraries that try us to run native code. So how do we compile them? We must rebuild them for a different standard C library. So in a regular build, we just execute native compiler. We provide source code, compiler makes a binary, or like the binary in this case, right, is a shared library. And then we load that library with load library call, and it does something for us. Well, it's very similar for making a cross build. We sit in a glibc or whatever based system, and we have a cross compiler, and we have a musl library. So we compile against it, and we create a different version of our shared library that will run in a musl powered environment. Well, we just change the prefix, right, to the compiler to perform that. And you see the binaries here, they are slightly smaller, and they're just different, and they run that code for us. Then you start some code in Alpine environment. Again, beware of some differences that it may show you. Even then we worked on JDK port, we faced different behavior in loading or resolving libraries with LD preload. Musl and Alpine are not unique here. AIX has its own standard C library implementation, so it's different from glibc as well. And others, which are basically won't be usable to you unless you try very oldish Alpine versions. So in all new versions, there's no such things. And yeah, diff debugger, you of course should put some extra configuration to make it work well. Also, you should remember about JDK being a JDK, so you can use all the packages, right, all classes from standard library, including graphics, even if you run it on server. So just beware and install necessary dependencies to do that, to perform actual rendering, because you need some resources like fonts for that. Again, please don't try very old versions of Alpine, because there might be some missing parts for native memory tracking, for example. As I mentioned, standard commands might be slightly different. You see, that's a case that we faced. One option is missing here, but you can use other options, right? That's not a big problem. Also, I don't know, whoever use serviceability agent, we'll see a small example. This is the part of this port that's just omitted. Beware of writing some shell scripts that you start in such an environment. Just be careful, use right strict syntax, put shebang in the beginning of the script. Then you pass some variables from your environment. For example, if you run in Kubernetes or Docker, or you just start your container somewhere. Variables with dots are maybe corrupted, but again, Alpine is not unique here. Just rely on your framework that typically allows or does the substitution for you, and you just write your variable names with underscores. So serviceability agent has been removed in newer JDKs, but if we talk about JDK 8, it's still there typically, and well, if you use that, don't expect it to be working in musl environment. So now the port is in upstream, in newer JDKs, in JDK 16, but that doesn't mean it doesn't work for older ones, right? There's now an official port in OpenJDK 11, and yeah, we'll see that slide later, which is widely used, and it's becoming a new JDK 8, but I think that won't last for long because it's much easier to migrate to newer JDKs from 11. So now you just take the most recent update, newer than the one listed here, and you get it from the same source from standard OpenJDK repository. And other systems like OpenWRT and other systems that I'm starting to talk about. Like here, in our company, we heavily use Linux, like this laptop runs Linux. We have a lot of build servers building JDK running Linux, and JDK is the JDK for Linux. Of course, it's the most popular, and we also have former engineers that worked on Oracle Linux. And it's interesting that we constantly look at the area of containers, of how make them effective. So we realized that containers can be made more effective if we improve the OS part. We really like the result of creating small containers with Alpine Linux. But there are still some issues because many users want a single provider of this combination of this stack of your Linux and your something, JVM runtime. It can be a classical JVM or it can be native image. And how it's supported, how security is managed, how it's updated, how all is aligned together. So to blame and to put everything, bring everything to a single window. Well, it's possible. You can just build a distribution that will be still as small as Alpine, will have understandable support, and to improve some performance aspects of this Linux, looking at how it can help your Java applications. Well, first, a few words about the support. As you create and support Linux distribution, we declare some support cycle and release cycle, and currently it just has been released, the Alpaquita Linux. Its version is 22 stream, but 22 LTS is on the way. You can get information about CVEs for every release. You probably know that supply chain security is a big issue, and it's better to manage it, and typically it's not that easy. But if we look at performance results, which is the most interesting part to me. Well, this distribution starts very fast. If you put it in a bare metal or in a virtual machine, it's just instant, even compared to well-known competitors. There's also, there are many benchmarks that we try to find relevant ones to measure how operating system helps your real production workloads. Like this stream workload is about moving data in memory, and you see again there are some interesting options here. Options include Alpaquita, but 3 Alpaquitas. And if you can imagine, the Alpaquita is a very small and cute alpaca, which is also small even if it's big. Alpaquita, they have different standard libraries. In Alpaquita, we have 3 options. The default option is called musl perf. It is an improved version of musl. Where's the improvement? We took some parts that we think critical and provided extra CPUs and or ISA specific optimizations for that functions. That didn't blow the library very much, and we can control the change and keep track of it, but they really bring some performance. So that's musl perf, which is slightly larger than stock musl, but it's more performant, and here we see how it's more performant. And also, we ship a glibc, the glibc library as a package in this operating system. So you can just install it or take the base image, which is glibc based, and have full compatibility with all your code that requires glibc, probably your third-party packages, or you can run glibc based JDK there. So again, in string operations, this is the area where we see a really big difference between stock musl and musl perf. Because many string operations can be improved by specific ISA optimizations like vector instructions. And they are just don't covered by generic musl implementation. This length of about 30 characters is very, very common in many, many applications. So that's why it deserves a separate slide. Again, for larger strings, the optimizations can bring you even more benefit, especially for very, very long strings, like thousands of characters, right? And you see the big difference here. JVM is not the only thing that can be put in a container or in a virtual machine or on a bare metal machine running Alpaquita. Other components and other languages are welcome and are provided as packages. There is a package repository managed by BellSoft with builds of all the packages. And here you see the benchmarks related to Nginx. And again, having musl perf is beneficial. Finally, we came to some Java results. Well, Da Capo is a well-known Java benchmarking suite. It's run here via Phoronix, but anyway. We can see more Alpaquitas, even more Alpaquitas, a big crowd of them. What are them? Well, besides of providing few standard C library implementations, Alpaquita contains few memory allocators that you can easily interchange. Those are gmalloc, for example, which is quite often can be seen with Java applications. This is memalloc. rpmalloc. So you see, in some even Java benchmarks, your system memory allocator makes some difference. Why does it happen? Well, actually, JVM manages and allocates memory for your Java code itself. So it has its own allocator. But JVM uses system memory for some internal objects. It's a C++ program, and it works in your operating system and uses the allocator that you told it to use. So that's why we see such a difference here. You can actually read slightly more about all the benchmarks in a dedicated blog post, which will be published on our blog, I think, today. So just check it out. I'll put the link in the last slide. If we compare bare allocator performance, there's clearly a difference, but some allocators are better in some benchmarks and others show the reverse result, right? There's no single, the best, very best allocator for your Linux operating system. And what happens with size? With size, if we build containers based on Alpaquita, and where do we get them? Well, they are already available on Docker Hub for free. You can have a more performant Linux with JDK combined together, perfectly optimized and tested as a container. And that will be still that small container, right? They are just called Liberica runtime container. And here are examples of tags that you can use for JDK 17. There are, of course, other versions. It's about 70 to 80 megabytes over the wire and slightly over 100 megabytes on disk. We decided to include font config for now as a default for that systems. Probably we should have more images even without font config to be on par with what's now in Alpine images. So you see base Alpine image right here. And the base image for Alpaquita is slightly larger, right? It's called it's Alpine base stream musl, and here's the date. It's slightly larger. And there's also a base image with glibc, right? And it's such a base image is combined with either musl-specific or glibc-specific JDK, and then you get your final resulting base image. Using a combination of Liberica native image kit and Alpaquita Linux can really improve your response time, your latency, your throughput. It is a subject of separate talk, but I can just show you some advertising plots here. So how do we choose the options? What should we take as a base image for our container, right? Well, you have to decide what you really need. What standard C library, is glibc compatibility critical for you or not? Which environment in terms of operation, do you use shell or package manager? If you don't need them, well, probably distroless should be better for you. If you build a native image, there's a different story because you can. There was a talk about this, by the way, here on Devox. You can even use Scratch container and link musl library statically, or you can build kind of regular native image and put in an Alpine environment, or Alpaquita environment, or you can build a glibc-based one. Again, glibc Alpaquita will play a good role here. So in some specific cases where you need something from a certain operating system, like we use Ubuntu because some component that we really require to install. Well, okay, take that image, right? And you'll probably get much larger container, but you will have that component available. If not, well, take Alpaquita, right? Just choose the right system library, and that's it. So, I hope that I convinced you that small containers really help. They help our productions, they save our money, our time, and our nerves. And they can be made even smaller if we bake them properly. Just remember to select not something random from the internet, but choose your provider wisely. And small containers can be made more performant by a slight amount of optimizations in that special standard library. And they are already available now. Okay, thank you. I would be happy to answer some questions. Yeah, by the way, here's the link to the blog, or you can follow me on Twitter or ask your question on Twitter. Yeah? All right, if no question. Oh, one question.
Yes, there are JRE-only versions or just versions?
Yeah, the question is if there are JRE-only versions of these images. Yes, there are JRE-only versions, but the fun part is that it actually, there's no difference in size. Because in modern JDKs, there's no such thing as JRE, actually. You just exclude some tools, but that doesn't give you, well, big difference in size. It decreases the number of things that you have inside the image, right? So you kind of feel more safe. Yeah. Just change the word JDK to JRE, and that's it. Yeah, in the text. Yeah, any more questions? All right. It was a pleasure to see you all. Safe trip home. Bye-bye.